Right, so this last few slides, I'll just show you quickly the relationship between the geoid, the ellipsoid, and how they relate to the center of the Earth. So as I said here, we call this a geocentric datum because it uses the center of Earth as the origin. So we've got a smooth representation of the surface of the Earth, a very smooth ellipsoid, we might call it. So the ellipsoid, this one here, is the smoother surface. So it's the one that is easy to define mathematically because we've decided that we are going to create this smooth surface that provides the best representation for the surface of the Earth. And then we've got the geoid, which is the one that takes the effect of gravity into account. And that is a bit more, so it undulates, it's not as smooth, but it's important for us to know the relationship between the two, because you might need to sometimes transform between them, because the geoid is in a lot of cases, it's the closest representation to mean sea level. So if you're working on a local datum, obviously mean sea level is one of the heights that you are interested in. But let's say that you are using GPS to calculate or to measure heights or to observe heights, and then you might need to go between one type of datum to another when it comes to heights as well. So there's just something to keep in mind. And in a minute, I'll show you an example of the different types of heights, above mean sea level, as well as the ellipsoidal height, and how to calculate or go between them. Right, so going back and reviewing, we can have two different types of ellipsoids. We can have a global ellipsoid as well as a local ellipsoid. An ellipsoid is a smooth, easy to interpret mathematical representation of the surface of the Earth. And we have a global one that creates the best fit for the entire Earth. And examples of that is WGS 84 and GRS 80. And then we've got a local ellipsoid that provides us the best fit for the local topography. An example of that in New Zealand, obviously, you know that we have NZGD 2000. That's an example of a local ellipsoid. Okay, so it creates the best fit for that particular area. And every country might have their own locally defined ellipsoid. And then if you're using GPS, and obviously you can transform and go between one or the other. Right, so now we are going to go to the geoidal height. So we're going to look at the relationship between the heights when it comes to ellipsoids and geoids, and we call that the ellipsoid-geoid separation. So at any point on the geoid, it is the vertical distance between the ellipsoid and the geoid. So we've got a ellipsoid, we've also got a geoid. Okay, this is our geoid. This is our ellipsoid. So the difference in distance between the two, difference in height between the two, normally we give it a symbol n, represented as the letter n. That's what we call our geoid height, or the ellipsoid geoid separation. Okay, and in most cases that distance is less than 100 meters, but it can go much higher than that. So obviously you need to be careful and aware that there could be some variations between the geoid and the ellipsoid, and just being aware. And this is how to determine the relationship between the heights. So this is a point, this diagram here just shows us the ground surface. It also shows us the geoid and the ellipsoid surface. So you can see them here. Take your time looking at this diagram here, but all we're assuming here is that this point on the surface of the Earth was measured using a GPS. Let's say GPS unit was put on here. Now, what height would be observed using GPS? And the answer is the height above the ellipsoid, because a GPS uses a global datum. Okay, so the GPS uses a global datum. If the GPS is using a global datum, that means that that global datum is the surface of the ellipsoid, okay, above the ellipsoid. That would be our datum. And because of that, we call that the ellipsoidal height. So obviously ellipsoid, ellipsoidal height. Okay, so that one is easy. The next one is if we have if we know the geoid and we have the surface of the ellipsoid, as I mentioned in the previous slide, the height difference between the ellipsoid and the geoid is given that letter N. That would be our geoid height. Okay, so height difference between the geoid and the ellipsoid. And what we're left with here is that if we want to define the relationship between the ground surface and the geoid. So in this case, it's this height here. It's given by that symbol H, that letter H. And that would be what we call our orthometric height. And our orthometric height is calculated by taking the ellipsoidal height and subtracting the geoidal height from it. So look at that relationship here, make sure that you understand it, and make sure that you've got this formula correctly, because a lot of times we like to use this equation quite a lot, and it's important for your career, also your career surveyors as well, to be able to go between the geoidal height and the ellipsoidal height. So yeah, pay attention to this slide. So before I end the lecture, I'm just going to leave you with some things to think about and reflect on this session, see what you've learned. And the first question is, when you take observations on the Earth's surface, what are we observing in reference to? So obviously think about that. It was the main topic that we covered today, taking observations on the Earth's surface. So just note the word Earth's surface. What are we observing in reference to? Next question. Are there different surfaces that we observe on? If so, what do you know about them? So again, going back to reviewing the different surfaces of the Earth and the relationship between them. So just giving you the opportunity to think about what you've learned when it comes to the different surfaces of the Earth. And finally, what are we doing to these observations once we collect them? Do we use them in their raw format, or do we do something else to them? So again, if you can think about two scenarios, one being a local datum. So if you're working on a local survey, so small area survey, and then if you're carrying out a geodetic survey. Okay, so what is the difference in observations? What are we doing with these observations once we collect them? And do we use them in the raw format, or do we do something else with them? So I'll leave you these questions, and we'll gather again next week and we'll go through the answers of these.